Hello everyone, this is Usman Imam. Welcome to my channel Need to Know. In this video, I'm going to tell you what you would need to know about stealth technology. But before diving into stealth technology, we must know something about radar systems. Radar refers to radio detection and ranging. And the radar theory based on transmitting of an electromagnetic wave and receiving it is backscattered when it is obstructed by a target. Through this range, azimuth, elevation, height, and speed of the target are determined. Power intensity from isotropy antenna is given by the total power over an area of a sphere with radius r, where Pt is the peak transmitted power and r is the range of the target. Power intensity from a directive antenna is given by where Gt is the total gain of the transmitter, and it is defined as the radiation intensity of an antenna in a given direction over that of isotropy 1, and it is given by where A is antenna area and lambda is the wavelength of the transmitted wave. Radar cross-section, ρ, it is the radar signature, and it is a measure of energy that radar target intercepts and scatters back towards the receiver. The power reflected at the target is given by, and it is clear that the affection and the effect of radar cross-section area. The power density of the reflected signal is given by the power density reflected by the target and received by the radar is given by where AE is the effective area of the antenna and GR gain of the receiving radar antenna. Noise effect in radar systems is measured by signal to noise ratio. The noise is given by, and signal to noise ratio is given by where K is Boltzmann constant, Ts other sources noise, Bn noise bandwidth of the receiver, L total system loss, and F noise figure of the receiver. These two equations were the keys of stealth technology: reflected power and signal to noise ratio. The first operational use of radar systems was during World II. The British chain home radar played a critical role in Battle of Britain 1940 by supplying an early warning of German air raids. it was the large-scale use of radar systems. Throughout the Cold War and post-it, radar systems advanced very rapidly, and many types and uses were introduced, like weather radars, surveillance radars, air traffic control radars, and tracking radars. Tracking radars were the most important ever introduced. Stealth technology, sometimes called low observability. It is a technique and technology meant to make aircrafts, ships, missiles, and ground vehicles invisible or less observable for radars, sonars, or any other detection means. Stealth technology started with reduction of radar cross-section, backscattering of backscattered or absorption, and infrared suppression. The concept of the technique based on shape of the airframe. The classical shape of the airframe must be changed to reduce the radar signature without loss of aerodynamics, of course. Radar absorption materials, infrared suppression systems, electronic warfare countermeasures, and sound suppression systems. Airframe shape must be with tilted fins or no vertical stabilizers, delta or flying wing, angled leading edges, embedded engine over the wing, serpentine engine air intakes and exhausts, angled surfaces, and internal weapon bay. The German Horten 229, although it is not practically operational, but is the first conceptual design, features the geometry of stealth aircrafts. Featured with flying wing, no vertical stabilizers, and embedded engines. Also, use of composite materials, angled spars, and wood were traced on the construction of Horten 229. Radio absorption materials. They are materials especially composed to absorb radio frequencies rather than reflecting them back as effectively as possible from any incident direction. The keys of the technology are materials composition, foams, composites, coating fusion and paint, and also multi-layered structure. Infrared suppression systems. The infrared spectrum over the skin of the aircraft could be like this. So, minimizing hot spots by insulation, engine placement in the body shield by the airframe, cooling, either air cooling or cryogenic cooling, serpentine air intakes and exhausts to expel the hot gases opposite to the direction of the acoustic sensors and infrared detectors. Electronic warfare countermeasures. It is an electrical or electronic devices meant to deceive, trick, or jam enemies' radars, sonars, or any other detection methods by jamming, either noise jamming, barrage jamming, or spot jamming, or by deception, by means of spoofing, falsifying the radar signature, or decoys, sending shafts and flares. Sound suppression systems. Sound suppression is critical for stealth aircrafts, while the primary focus is often goes to the reduction of radar cross-section and suppression of infrared. Keys of the technology are engine choice. High-pass turbofan engines are the most favorable for stealth aircrafts. Engine placement embodied in the body shielded by the air structure or the airframe is recommended. Here are some examples of stealth aircrafts. Lockheed's SR-71 Blackbird is the first practical stealth aircraft. Although it is not completely stealth, but it is with significant low radar signature. Featured with tilted fins, angled leading edges, ram, black coat, and rear mount engines. Lockheed's F-117 Nighthawk, another contribution to stealth. Delta wing, angled leading edges, tilted fins, angled embedded engines in the body, angled air intakes, and ram and IRSS. Northrop B-2A Spirit. It is the state of art of stealth technology in the late half of last century. Featured with no vertical stabilizers, flying wing, embedded engines over the wings, angled leading edges, ram and IRSS. Lockheed's F-22 Raptor is the first fifth generation stealth aircraft introduced. Also, tilted stabilizers, angled leading edges, angled engine air intakes, ram, IRSS, and ECM. The Russian MiG-41 is a piece of fiction sixth generation stealth aircraft. It is called the Black Star and sometimes it's called the Last Star, although it is not delivered to the Russian Air Force till now. Tilted stabilizers, angled leading edges, serpentine engine air intakes and exhausts, ram, IRSS, and ECM. Russian Su-57 is another fifth generation contribution to stealth aircrafts. Tilted stabilizers, angled leading edges, angled engines, air intakes, RAM, IRSS, and ECM. The Chinese J-20 is another fifth generation addition to stealth aircrafts. Tilted vertical stabilizers, angled leading edges, angled engine air intakes, RAM, IRSS, and SSCM. The Chinese J-20 almost looks like a copy of F-22 Raptor, but it is with a double canard configuration, while F-22 with trapezoidal wing design. This is the Chinese J-20 and this is USA F-22. From the front elevation they look like, but they differ into configuration. Configuration is different. This is the J-20 and this is F-22. Well, we conclude with the introduction and fast advancement of radars systems became a threat for aircrafts to conduct air raids safely, so going stealth was crucial. The German Horten 229 could be considered as an inspiration of stealth technology design. Airframe shaping, RAM, and IRSS are the main features of stealth aircraft design. Stealth aircrafts remained vulnerable during ground attack and air refueling. During ground attack, it must open the weapon bay. At that moment, it becomes vulnerable. And the same goes to air refueling. Aerodynamics presents a great challenge to stealth design, especially stability and controllability. F-22, F-35, MiG-41, Su-57, and the Chinese J-20 are the dominance of stealth space for the time. There are researches going on to clone SR-2, SR-71 to SR-72, and another serious program for next generation air dominance NGAD is going on. Stealth aircrafts become reality but remain with very high cost to achieve, and concerns of being brought down by a cheap piece of technology would shelve it or send it to junk. Well, if you like my video, please send me like, share, and subscribe. Thank you.